Question is from JAMB 2010 and is under naming of organic compounds. Can you answer it? Okay, see another one here. 2011, question 46, also from organic compounds, naming organic compounds. Look at another one, 2013, still on organic compounds, asking whether this compound is an alkanone, an alkanoid, an alkanal, or an alkanol. Here is still another one, 2013, asking for the IUPAC name of this compound given here. I can continue on and on to show you how JAMB asks questions and to prove to you that every year JAMB asks 1, 2, 3, or 4 questions from this aspect of naming. Aside that, I've observed that organic chemistry, which usually are the questions that come towards the end of chemistry subject in every JAMB and every year, has a good number of questions, that is up to 4 or more. This is why you need to master this subject very, very well. If you are my students, welcome on board. And this is our first lesson on chemistry, mastering how to name organic compounds, getting yourself familiarized with it. If you are not my student, that is, you are not in our learning group, you are still welcome. And I hope that this lesson today is going to expose you and also help you master how to name every compound that you come across in JAMB. Having established that this is a question that you cannot escape anyhow you want it in JAMB, it is therefore wise to master how to name it. And this is what this lesson is going to be all about today. Welcome once again, and let's get right into it. So the first thing in naming organic compounds is that you need to master a few basic things. One of them is that you need to know how to name the first 10 members or the first 11 or 12 members of the alkane, alkene, and alkyne groups. But in this lesson, we are going to concentrate more on alkanes. It is also important to know that organic compounds are named based on their base, the suffix, and the substituent. And this is very important for you to know too. So we are going to continue from this point. I believe you are familiar with methane, ethane, propane, butane, pentane, hexane, and so on. So that if you are asked, once you hear pent, you know that is a member of organic compounds that has carbon number 5 or 5 number of carbons. So let's go right into it. This is very important. Do you know that these two are the same thing? Yes, of course they are the same thing. And this is a basic thing you should know. So that if they just draw a line, a dash in chemistry, or they draw something in a zigzag format, you should know that it means a compound, and you should be able to identify the number of carbons in that. So if you look at this compound carefully, you would observe that they are the same thing. So it means that at every corner, at every end, there is a carbon. That is what this means. If you look at it, you observed, you can count the number of carbons on the straight line. You can see the number there. We have, 1, 2, 3, 4, 5, 6, 7. We have 7. So also, if you count the straight chain on this other compound, which is not showing carbon or hydrogen or anything, you would also see that we have 7 carbons. The line that is down is for the methyl group, which is attached here. I just want you to be familiar with this so that if you see a zigzag form with OH, you will be able to know the number of carbons there and also be able to name the compound easily. This is basic and you must know it. So let's go. All right, so we are going to start naming now, but before we start, there is a need to understand rules. My students last year, this was our major focus. Let me tell you, in every subject, there is a lot. But if you can master the basic principle, the basic secret, then you can do anything. So, however bulky a topic is, there is the main thing that you are expected to know. And once you know it, you are good to go. So this is one of the principles we have been applying, which has been working for us. I showed the results of some of my students last year. I don't need to show it here because I don't want this video to be long. So in these organic compounds, one thing you need to know, and one thing I will beg you to know, is to know the rules in naming organic compounds. Please, if you have your book and your pen, bring them closer now. Bring them closer because you may need to write some of these things. You may need to master them. You may need to rehearse them. You may need to know them. This is what helped me in such a way that after I mastered all this rule, any compound you bring to me, any compound in chemistry, I would answer that question of naming it because I was able to master these rules. And that has helped me a lot because on several occasions, not only naming is matters, there is need for you to name and also know the characteristics and some other things, which we are going to consider in the next lecture, because I've observed that from aside of naming, there are also questions, significant number of questions in properties of organic compounds and so on. We are going to deal with that in a separate topic. So let's go. What's the first rule in naming organic compounds? The first thing that will help you name every organic compound is to know the fact that organic compounds are named based on the longest carbon chain. This longest carbon chain is also called parent chain. That is to say, whenever you come across a compound, the first step to naming it is to count the number of carbons in that compound. The longest chain is usually considered. Look at this example. So, assuming we want to find the longest carbon chain in this compound, look at the first one where it starts counting. 1, 2, 3, 4. You can see the red line there. Look at the second one that gave us 5 carbons. 1, 2, 3, 4, 5. So the second one is correct because we have the highest number of carbons in that. That is to say, before you can name any compound, try to know which direction gives you the highest number of carbons. And let me tell you something. You can start counting from the bottom. You can start counting from the left-hand side. You can start counting from the right-hand side. You can start counting from up. There is no rule as to where you should start counting. I hope this is very clear so that you will not assume that you must always start counting from the left-hand side to the right-hand side. No, it's not a rule. Please know this. Now, having said this, the first thing is to always identify the longest carbon chain. Follow me carefully. I'm going to explain everything in detail, and by the end of this lesson, believe me, you will be able to name organic compounds. If it has been a difficult thing to you, or if you have been able to name but you've not mastered it, at the end of this, you will be able to answer because I'm going to give you JAMB questions for you to answer. All right, so can we continue now? Yes, please, I would like to say this again before I continue. I always encourage seriousness in learning because if you cannot be patient and stay, you will not be able to learn. That's just the fact. So if you want to cook and the food cannot stay on fire for long to be cooked, of course, the food cannot be cooked. So that's the same thing with learning. So that's why anytime I want to learn, if I pick a topic like this, I will make sure I sit around it and make sure I get everything possible. So I wouldn't have loved this video to be too long, but then there is no option because I have like 6 rules to reveal to you in this video. And if you are not patient enough to sit down and get these rules, believe me, you can go. So I encourage seriousness. So if you cannot wait and sit down and get this thing right now, I would just advise you to go because it's obvious that it has to be a little bit lengthy. But if you are ready, let's go. This is why I always tell my students, and I have to be I have to be clear with this so that you would know. Thank you. So let's go. I hope you have understood the first rule now. Always name the longest carbon chain. Identify the parent chain. Having said that, let's continue. So, look at another example. You need to get it too. You need to get it. So, look at this example. In this example, there is a counting in different directions. So, from left to right, left up, in the second one, and the third one at the bottom here, you can see it even started from this direction and goes up. Now look at the first one gives us 10 carbon, the second one gives us 10 carbon, but the third one gives us 11. Do you observe that? And of course it's the correct one. So do you now see why I told you that there is no rule as to where to start counting? You can start counting from up, you can start counting from left, you can start counting from right. So I hope this is very clear, because if you are not able to understand this, you will mix everything up. Some people would always think that to start counting, to identify the parent chain, you always start counting from the left to the right, as it is in the first compound and the second compound. No. So you can see obviously that the correct parent chain is the third compound at the bottom here, and the counting started from the right towards the left and then up. I hope this is clear. So let's continue. Okay, so that is the compound that we have with 11 a number of carbons, and then we have the substituent. Any part of the compound that does not fall within the parent chain is referred to as substituent. You need to get this also. So we have parent chain, we have the substituent. The substituent can be a functional group, it can be another group else. But very soon I'm going to also explain this. Now remember, 11-membered carbon, if the parent chain has 11, it is undecane. Decane is 10, nonane 9, octane 8. Do you remember? Heptane, hexane, pentane, butane, propane. Do you remember all this? So now, but at carbon number 6, there is an attachment which we call a substituent. So usually you name substituents first. I'm just saying this thing, I'm going to explain them again because I want you to master this thing. So if you observe this green part, we have how many carbons do we have? Can you identify? Remember, I told you can see an arrow, a zigzag form anyhow. So now, at the beginning of that line, there is carbon. So that's 1, the first angle 2, the second angle 3, and the third angle 4. That's 4. So we have 4 carbons on that side chain on the substituent aspect. And 4 carbon member is butane. But because it's attached, it's usually called butyl. Butyl. So look carefully, you would observe that this butyl is attached to carbon number 6. Carbon number 6. So the name would now read like as 6-butyl undecane. Do you see how it is named now? The position where the substituent is attached, then the substituent, then the parent carbon chain. It's very simple. Every naming, that's how it follows, except the basic ones. So first, the position where the substituent is attached, that's the number, in this case at carbon number 6. Now let's look at something. Let's do something carefully. Assuming we start counting from up, what will this carbon number where the substituent is would be? Let's say 11 will now be 1, 10 will be 2, 9 will be 3, 8 will be 4, 7 will be 5, 6 will still be 6. So, which means that even if you start counting 1 from up, down, you are still correct, because that position would always be 6. I'm going to explain something very important in another rule as we continue. All right, so let's look at this. So I hope you get it now. So look at this now. Look at this. This is explaining something that I wanted to say previously that I say I would say it later. So here now we have 2 compounds. One is incorrect, one is correct. So you can see the naming, the numbering starts from chlorine, close to chlorine, the first carbon after chlorine. So we have 1, 2, 3, 4, 5, 6. So also if we start counting the other way around, it will still give us 1, 2, 3, 4, 5, 6. But what's the difference? Now look at the substituents. We have chlorine and we have bromine. And if chlorine and bromine are substituents, they are referred to as chloro or bromo. There is where I'm also going to talk about that briefly. So now, what makes the first one wrong? If you have more than one substituent, the substituents are listed alphabetically. For example, chloro starts with C, but bromo starts with B. So B and C alphabetically, which one comes first? B, of course. So bromo must be mentioned first before chloro. That's why instead of starting from chlorine, because you need to give the substituent the lowest number possible. Instead of starting from 1 from chlorine, we now start from bromine. Because look at this. You can also decide to name it as this incorrect one. You can also decide to name it as 6-bromo. I hope you are getting it because the bromine is at the position 6. So what if I say 6-bromo, 1-chlorohexane? Is that not also correct? Very close to being correct, but it's not correct. The reason is because the bromo, the first to be mentioned, should carry the smaller number. But this case now I'm saying 6-bromo, 1-chloro. Do you see it? So 1 should come before 6. Do you get my point? So that's why the numbering is correct in the other side. I hope you get it now. Please and please, if you didn't get this, just go to the comment section and say, at a point where you are explaining the position of chlorine and bromine is not clear, I will find a way to reach out to you and make it clear again. I wouldn't want you to miss anything. If you have devoted your time to master this, you shouldn't go with anything unclear. Please and please, I urge you. So if at any point you didn't get anything, please. And at the end also, I would ask you to help me because I'm on a mission to assist people who are really serious but need guidance. I started this since last year and I've been able to support a lot of JAMB candidates to get 300 and above, 200 and above. I have a lot of students in the last JAMB that scored that. So, and I would like you also to score such because it is very, very important that people who are serious should get the necessary support to get entry into the university and into their courses of choice. So at the end also, I would ask you to rate my explanation because I want to improve. If I'm explaining, I'm wasting my time and you are not understanding, it doesn't make sense. So can we go ahead? I hope this is clear now. Yes. All right, let's go. Good. The second rule, identify all the substituents. Okay, I've started talking about substituent already, but in this case, we have a clear example. So anything that does not fall into the parent chain is referred to as substituent. So in this case, you could see the substituents in red circles because they didn't fall into the parent chain. So they are referred to as substituents and you name them. All right, so let's try naming this compound because I want you just to get it. I just want you to get everything as much as possible. So now look at this compound. Let's start naming it. Now, if you observe, the substituents we have are methane. Let me use that word now, but it's actually 1 carbon, 3 hydrogens on 1 carbon, and then we have another one there. So I said if it is a substituent, instead of saying methane, because 1 hydrogen is not there, so it's methyl. So how many methyl groups do we have? 3, and they are the substituents, all of them. So let's now start counting to see which direction should we count. Now, if we start from this end, we have 1, 2, 3, 4, 5. That's pentane. We can write that separately. We know that the parent chain is pentane, which is actually the last name always. Now, let's name the substituent. Which direction should we count? Is our counting now correct? If we go from this direction, at carbon number 2, we have 2 methyl groups. That's dimethyl. So, and at carbon number 4, we have 1 methyl group. So that will give us 2 dimethyl. No, it's not 2 dimethyl now. All of them are methyl. So the name has to be the same. So what do? We can say 2, 2, then 4 trimethyl pentane. listen to me carefully. 2, 2, at carbon number 2, at carbon number 2 again, at carbon number 4, we have 3 methyl and then parent group. Is this too hard? No, it's not too hard. So we have, I'm counting from this direction now. At carbon number 2, I have methyl up, methyl down. At carbon number 4, I have methyl up. It doesn't matter whether it's up or down. But at carbon number 2, we have 2. At carbon number 4, we have 1. That's 3. All of them are methyl. That's why we are joining them together. So all we need to do is to mention their position. So in this case, we have 2, 2, 4, trimethyl pentane. And even if they give you that name to write, is it too hard? It's not too hard also to write it, assuming you are given the name and you are asked to write the structure, because it also comes in that way. So 2, 2, 3, 4 rather. 2, 2, 4, trimethyl pentane. So assuming we are given this name, what do we do first? We write the pentane parent name. Pentane, that's 5 carbon. Then it is said 2, 2, 4 tri. That's 3 methyl. Then you come to carbon number 2 and put 2 methyl. Then you go to carbon number 4 and put 1 methyl. It's very simple. So either way, either to name or to write the structure is very simple. I hope someone got this. If this is not clear, go to the comment section and write rule number 2. I will explain rule number 2 again to you, even if it is on a private chat. I will see it and I will explain again. So now, how the substituents are named, though I've started introducing this, but let me make it more clearer again. So if you are dealing with halides, what are halides? Halides are group 7 elements. I hope you did not forget this. The name halide means salt formers, and we know they are the most reactive elements. Fluorine, being the first member, is the most reactive element on Earth. I hope you didn't forget these basic things. Yes. So if you find fluorine attached to an organic compound, it is usually fluoro. Fluorine as a substituent is fluoro. So all the halides coming as substituents, they carry that OO, fluoro, chloro, bromo, iodo. I think we have said something like this earlier. Yes, in one of the namings. So what of alkyl groups? Alkyl groups, CH4, that's methane, it will lose a hydrogen. So if it comes as a substituent, it's usually CH3 and it's referred to as methyl. We have ethyl, that's 2 carbon. We have propyl, we have butyl, we have pentyl, in that order, depending on the number of carbons. So alkyl groups, they end with YL always, while halides, they end with O. You are going to understand this more clearer. Even if it is not clear, just follow me. I'm going to explain it better somewhere. All right, so let's look at this example now. Let's look at this example. So identify the longest carbon chain. Of course, the longest carbon chain in this case is just directly clear. So if you count now, which direction should we count? Let me see if you get though the name is there. Okay, so we are starting from this direction to this direction. I hope you see that, because bromo come before methyl. I told you substituents are also mentioned alphabetically, according to alphabetical order. So B comes before methyl. Of course, we have 2 substituents there. I hope you are seeing them. So if you count this way, methyl will come at carbon number 2, while bromo will come at carbon number 3, which is wrong. So it should be bromo, which should be first mentioned because it's B. It starts with B, should first come. So it should carry the smallest number. That's why we started counting from this direction to this direction. So we have methyl. Sorry. We have the parent chain is butane now, 4 carbon, butane. But on that butane, we have bromine at carbon number 2, and we have methyl at carbon number 3. So this is very simple. What I usually do when naming is that once I identify the longest carbon chain, I will write it down. In this case, butane, I will write butane down. Then on that butane, what do I have? I have bromine. At what position? Carbon number 2. So I will write 2 bromo. Then I will go, what else do I have? Methyl. At what position? Carbon number 3. I will write 3 methyl. Do you see that it's very simple? So with that, I will now have, okay, 2 comes first, so it will now be 2-bromo, 3-methyl, butane. I will just bring the names together and put it. Very simple. All right, so I hope this example is very clear too. Let's go. Good. Hey, see another example. Now, I want you to observe something very carefully. Remember, we are still talking about the rule for substituents, identification of substituents. So look at the naming, look at the numbering first on this compound. So you could see your 1, 2, 3, 4 up to 9. If you count in any other direction, you may not get up to 9. So that's our longest carbon chain. I told you in counting, you can even go up, go down, come zigzag in different directions, provided that you did not break the line. You can start from up, go down, go this way, go up, go any direction you can go. But you should not cross a line and you should not jump. So in this case, you can see how our 1, 2, 3 to 7 go up, 8, 9. You see how that goes. All right, so that's the longest carbon chain. Any other thing that remains is referred to as a substituent. So you can see our substituents in green, and then there is another ethyl there. So which direction should we go? Now I want to show you something again based on this alphabetical order of naming substituents. Because we started counting from here, this direction, so we have 1, 2, 3. At that carbon number 3, what do we have? We have ethyl. We have ethyl, that's 3 ethyl. Now, assuming we start counting from 9, 9 to be 1, 8 to be 2, 7 to be 3. Yes, that way we can have methyl first. That would have been 3-methyl. I hope you get this. But then we cannot count in that direction. Why? Because methyl and ethyl, alphabetically, ethyl comes first before methyl. I hope you are getting it. Assuming is this methyl on carbon number 3 that is here at carbon number 7, our counting would have started from 9, 8, 7 in that order. 9 would have been 1, 8 would have been 2, 7 would have been 3. I hope this is clear. So you have to consider alphabetical arrangement also in counting. This is very, very important. Can you name this now? Let's try it now. So you see what I've been telling you. So the parent name is what? Nonane, that's 9. So on nonane, what do we have? We have methyl on carbon number 3, ethyl rather. Then we have methyl at carbon number 4, and we have methyl at carbon number 7. So how do we name this? We first of all name based on alphabetical order. So we have 3-ethyl, 4,7-dimethyl. I hope you get that. You see, you have to bring them together because they are the same thing. You cannot say 4-methyl, 7-methyl. No, it's not done that way. You only mention the numbers together and then put the number of the substituents because they are the same thing in that order. I hope you get that. Remember again, our parent chain is nonane, 9. Then we have ethyl must come first because E comes before M in alphabetical order. So we have 3-ethyl, 4,7-dimethyl. I know you know di means 2. 2-methyl. Nonane. Very good, very good, very good. All right, so I hope you am I the only one that named it, or you also getting it? All right, so if you are getting it at this point, I would really like to get your feedback. Are you getting it? Is it interesting? Please pause and drop a comment. Let me know what I'm doing. Okay, should I wait for you? Yes. Okay, go to the comment section and let me know. Are you getting it? Just tell me I am getting it. Your class is interesting, so that I will do another video. I don't want to waste time. I have a lot of things to do. Okay, are you doing that already? Okay. All right, like also, if you are learning, let me know. Did you hit the like button? All right, thank you. Let's continue. Rule number 3 says the number of carbons of the parent chain from the end that gives the substituent the lowest number. So I've already explained this in one way or the other, where I said the substituent must carry the lowest number. But let's look at this example. Okay, look at this counting from left to right and from right to left. So from 1 to 10, we would have a substituent at carbon number 3. On the other hand, if we start from right to left, we would have a substituent at carbon number 2. I hope you are getting me. Look at these two compounds. We are comparing both at the same time. If I start counting from this direction, the first substituent is at carbon number 3. On the other compound, if I start counting from the other direction, I would have substituent at carbon number 2 cycled there. So which one is the correct one? The correct one will be the second compound that gives the series of 278. 278 is preferred because once I start counting, I will meet a substituent, I will meet an attachment. Also, that's a rule. You must follow that. So in one way or the other, I have explained it previously, but I'm still re-emphasizing it now because it's a rule that if you miss it, you won't get it correctly. I hope this is clear too. So let's go. Rule number 4 says, if the same substituent occurs more than once, the location of each point on which the substituent occurs is given. In addition, the number of times the substituent occurs is indicated by prefix di, tri, tetra. Oh, I've explained this also. But look at this example now. Look at this example. First, identify the parent chain. Parent chain, how many carbons do we have there? 5. 5. So, we have 5. And we have substituents. What do we have? We have chloro there. How many? 3. At position number 2, at position number 3, and at position number 4. So how do we name it? Because the substituents are similar thing. So we just put the locations where they occur and put a prefix to indicate the number of them and then the parent chain. In this case, we have 2, we have 3, we have 4 trichloropentane. I hope this is clear now. I hope it is clear. Now look at the cyclic compound here. Having benzene, we have bromofluorochloro. Yes, something is mentioned there. Do you also see that we start from bromo? We go to chloro, and then we end with fluoro. Do you observe that alphabetically, though we start counting from chlorine? That's another rule in cyclic chains. You start counting from chlorine, then we come to fluorine, then we end at bromine. That's bromo. So though chloro is 1, bromo is 3, but we start mentioning bromo first, unlike in linear chains. In linear chains, we start with the counting from the direction of the substituent that has the lowest number, that will give us the lowest number. So in this case, we have different compounds, not the same, so that we could just mention the numbers and mention tri, di, or penta, or what. So in this case, we have different compounds and we name them accordingly. I hope this rule 4 is also clear. Alright, rule number 5 says, if there are 2 or more different substituents, they are listed in alphabetical order using the base name. Okay, so what does this mean? They are mentioned in alphabetical order using the base name. This I have also explained while attempting to name other compounds previously. So we have 3-chloro, 2-methylpentane on the first compound. These compounds are arranged alphabetically also. If you can observe, they are arranged alphabetically. The best direction to number the first carbon is from left to right, as you can see, so that we could meet the substituent faster, so that the substituent will have a lowest number possible. So in that case, we have 3, and chlorine is at carbon number 3. We have methyl at carbon number 2. So, but in naming, we have to prioritize alphabetical order. That's why we're having 3-chloro, 2-methylpentane. Okay, similarly, on the third carbon, you can now see on the third carbon, bromine is given priority because alphabetically, bromine comes before methyl. But on this case, methyl is given priority when numbering. The reason is because we meet it first, faster. That's why. But if we follow the other direction, we will meet both at carbon number 2. So bromine will be given priority because they start with B before methyl. So this is rule 5. We are almost done. Okay, look at this rule. Still on rule 5. Look at the counting wrong and right. So if you start counting from up, down, you have 7. If you start counting from down, up, you still have 7. So what makes this wrong and makes the other one right? Okay, let's analyze very fast and see. Okay, so if I start counting from up, at carbon number 3, I have methyl. And at carbon number 4, I have isopropyl. This is 3 carbon on carbon number 4 is a branch also, as you can see, is a substituent. So methyl and isopropyl comes at carbon number 4 and methyl at carbon number 3. So if you name from the other direction, you will meet the isopropyl at carbon number 4, which is also the same thing here. But in this case, we want to meet the substituent faster. Remember, that's the goal. So on the first compound, the substituent is on carbon number 3. But on the wrong one, the substituent is carbon number 4, which is far. So we'll prefer 3 to meet it fast, to meet the attachment fast. So that's why the first one is right and the second one is wrong. That's still emphasizing rule 5. So rule 6, before we call it a day, says if chains of equal length are competing for selection as the parent chain, then the choice goes in the series to the chain which has the greatest number of side chains. Yes. Okay, the chain whose substituents have the lowest number, I've said this earlier, the chain having the greatest number of carbon atoms in the smaller side chain, the chain having the least branch chain sides. Okay, so let's see. Yes, can you see this? Oh my God. All right, let me quickly explain. Look at the first compound there. So if we follow that counting order, 1 to 9, I hope you can see it, that incorrect. So you can see that we have substituent at carbon number 5 and carbon number 7. Then we have 9 carbons. So why is this wrong? Remember, we are talking about those that are competing. Now let's look at the one in the square, in the rectangle. The correct one. Look at the numbering. Observe the red line, that's the numbering direction. So this numbering starts from down and it goes up to 9. Now, in the first compound, what do you observe? In the first compound, we have only 2 substituents, that's 2 branches. But in the second one, the one in the rectangle, we have how many substituents? The green part, we have 3 substituents. Then if you look at the one at the bottom, it is also reading 9 as the longest carbon chain. Whichever direction you count, you are going to have 9. Now, which one do you take? You take the one that will give you more number of substituents, making the one in the rectangle correct one. If you observe, it is the only one having 3 substituents, 3 attachments. All these ones are having 2, and they are giving 9. But in the case where you have one direction giving more number of carbons, had it been now one of these gives us 10, we would have gone for it. But in this case, whichever direction you count, you get 9. So which one do you take? You take the one that will give you the highest number of substituents. I hope this is very clear. All right, thank you very much. Yes, we have now come to where I would give you some questions to try. Are you ready for that? Okay, before that, I will need to answer the questions we saw previously. I know by the time I open them now, you yourself might be able to answer some. So I have an assignment for you. Which do we do first? Should we answer the questions? Okay, let's answer the questions very fast. Let me see. Let's answer the questions. Then before I show you your assignment questions, they are typically JAMB questions, and you are going to answer them all. All right, so this is our first question. The first question says, the IUPAC nomenclature of the compound above is... what's the first rule? Count. Identify the parent chain. So observe something clearly here. The bottom has 3 carbons. The other side has 2 carbons. Then they are attached to the carbon there that has hydrogen. And then we have 3 carbons in the bracket and 1 carbon at this end. You have to be very clear with this. Very clear. 3 carbons at the bottom, 1 carbon. If we go this way, that's 2 carbons. If we come this way, the bracket has 3 carbons, and lastly, we have 1 carbon. So which direction should we count? Remember, our goal is to have the longest carbon chain. Now, let's start from this way and see what we have. Let's go straight. If we go straight, we have 1 carbon. We have 3 in bracket. That's 4, 5, 6, 7. If we go straight, we'll have 7 carbons. I hope that is clear. If we go straight, we'll have 7 carbons. Okay, let's go this way and come down and see how many carbons we will have if we have more than 7. Okay, so we have 1. In bracket, we have 3, that's 4. Then we have 5 plus the 3 down, that's 8. Of course, this gives us more carbons, 8. Remember, straight is 7. If we go this way, that gives us 8. So we are going to consider it. But then, if we go that way, we are going to have the CH2 now, the carbon number 2, this other part is going to be our substituent. It's going to be our substituent, which is going to be what? Ethyl, because it's 2 carbon. Now, how do we now go about it? Should we still go this way? Remember, another rule says the substituent must have the lowest number possible. So let's count to see if we can still have the lowest number if we go this way and down. Okay, so we still have 1 carbon. We have 3 here, 4. So it means that substituent is attached to carbon number 5 if we follow this direction of counting. Okay, let's count from down up. So from down up, we have 3, 4. So it means that at carbon number 4, the substituent is attached, which is lowest number compared to 5. So which means instead of counting this way, we are going to count from down, then we go this way. So at carbon number 4, we have ethyl. So the name will now be, remember, the longest carbon chain is what? 8 carbons, right? Yes, that's octane. So what do we have? We have ethyl attached at carbon number 4. So the name of this compound is 4-ethyl octane. A is the correct answer. Yes, JAMB 2011. Okay, so look at this. This talks about functional group. Of course, I'm going to make a video on other aspects of the organic chemistry, but let's see answer this. Functional group here, they are asking the functional group present in this compound above are. So what's the functional group? Anything outside the hydrocarbon groups are usually functional group. A functional group is that part of an organic compound that gives it its properties, that gives it its characteristics. So in this case, chlorine hydroxy groups are not part of the organic compound. They are part, of course, but they are not organic. They are not carbon and hydrogen. So in this case, they have the ability to influence the property, the characteristics, and the chemical activities of this compound. That is what makes them the functional group. So the correct answer is hydroxy and chloro group. Hydroxy and chloro group. Okay, A says alkene and halo group. No, that's not correct. Alkene and chloro group. We don't have alkene here. Of course, alkene is double bond, right? Did you see any double bond here? No. Double bond is also a functional group. Triple bond is a functional group, but they are not here. So all the A and C are already invalid. So let's go to the next question. The next question says the compound above is an alkanone, alkanoate, alkanal, and alkanol. Now let me make something clear here. Though we are still going to talk on this. But let's name this. Let's look at this carefully. All right, what are alkanones? Alkanones are ketones. We also call them ketones. So they usually have an oxygen attached to carbon in the middle, which falls under this category, and this compound is of course an alkanol from seeing it. Then alkanoid are esters. These esters usually have two oxygens in the middle, so this one is having one, making it not an ester. Alkanals are also called aldehydes. They usually have oxygen attached to the last carbon and a hydrogen to that carbon. So this is not an aldehyde. Then we have alkanols. Of course, you know alkanols. Alkanols are alcohols also. How do you know alcohols? They have OH functional group. In this case, we don't have OH. We have oxygen. That H that you are seeing close to is not part O, is attached to the last carbon. I hope that is clear. So, we still have one. Okay, very quickly. What's the IUPAC name of this compound? So, the first thing is to take the highest number of carbons, of course. So, we start counting such that we have the longest parent chain. So, which direction now? If we start counting from this direction, going this way, it will not give us the right thing. The reason is because we have two substituent, we have a functional group. Now, a functional group, some substituents can come as functional groups and some may not come as functional groups. In this case, we have an in group, an alkene group, double bond there. So double bond is stronger than a methyl group, so it's prioritized when you come to numbering, because sometimes you have two substituents, like I said, so you consider based on the alphabetical order. So even by alphabetical order, the in group, that's double bond, will get priority. So we start counting from this direction. So we have carbon number 1, carbon number 2, 3, 4, 5. So this is a pentane. This is a pentane, but at carbon number 1, it has in group and it has to be mentioned. And at carbon number 4, it has methyl group. So this gives it a name, 4-methyl pent 1-ene. The in group is at position number 1. In means double bond. Ine, Y-N-E, means triple bond. I'm still going to make another video on this aspect to explain how you can name all these compounds. All right, thank you very much. Let me now show you your assignment. It's going to be very simple, only 3 questions. How do you submit it? For those of you that are my students on WhatsApp, send it to my DM. The assignment you should do and finish it. Okay, send it tomorrow. If you are watching this video now, send it tomorrow, latest by 10 p.m. to my WhatsApp on my DM. If you are not my student and you wish to join, okay, okay, you can drop your answers on the comment section. I will still come and check it. And or if you wish to join also, you can show your interest so that you can join other activities we do on our group. Okay, we will see. This is the first question. It came out in JAMB 2014. If you have JAMB past questions, so you can go and check to confirm that I'm drawing from JAMB past questions. So this is your first question. You can pause, check the name, write it. Please don't just write A for me. Write A and then you write the name. Thank you. Then this will be your question 2. Just arrange them in that order. I'm clear. I know that this is carrying 34. The previous one is carrying 40 also. Just that first one should be number 1. This should be number 2. So what's the structural formula of ethanoic acid? Go and look for it and then choose your answer. We have A to E here. Then the last one, the name for this compound is, this was JAMB 2018. So this brings us to the end of today's class. If you are watching and you have learned something and you are preparing for JAMB and your goal is to score high, subscribe to our channel and please hit the notification button so that as soon as I uploaded a new video, you'll be among the first people to see it. Lastly, evaluate me now. I want to hear from you. Did you understand? Is anything not clear? Please write in the comment section. If I'm one of the best teachers that you've ever met in chemistry, let me also know. If I am too fast, let me also know, so that in the next video, because my goal is for you to learn. So please, I'm expecting your feedback. Oh, write it now. Thank you and bye.